Hello children, this video is part 5 of chapter 1 Chemical Reactions and Equations class 10. Before watching this part, it is strongly recommended that you first watch part 4 and then the things will be crystal clear to you. Here in this video, we will be balancing a chemical equation by two methods. First, by hit and trial method as given in our NCERT, and the second is by algebraic balancing method. This algebraic balancing method is a 100% successful method which will really make the balancing a fun. Let us see an example. Magnesium Mg plus oxygen O2 gives magnesium oxide MgO. Here the symbol of magnesium Mg and the symbol of oxygen O2, and the formula of magnesium oxide is MgO. This is a chemical equation which simply represents the symbols and formulas of reactants. You know that reactants are written on the left hand side of this arrow, and products which is written on the right hand side of this arrow. They are taking part in a reaction, and this is known as skeletal chemical equations. So a chemical equations simply represents the symbols and formulas of reactants and products taking part in the reaction is known as skeletal chemical equations for a reaction. Let us see another example. Nitrogen plus hydrogen gives ammonia NH3. So the symbol for nitrogen is N2, the symbol for hydrogen is H2. It combines together to produce ammonia NH3. So this chemical equation, which is simply representing the symbols and formulas of reactants and products taking part in the reaction, is known as skeletal chemical equations for a reaction. As you know that any chemical equation must obey the law of conservation of mass. We will be learning the balancing of each chemical equation by these two methods. So let us move on. Children, let us see an example. Here zinc reacts with dilute sulfuric acid to give zinc sulfate and hydrogen. The word equation for this chemical reaction is written as zinc plus sulfuric acid gives zinc sulfate plus hydrogen, and the chemical equation for this word equation is zinc Zn plus sulfuric acid is H2SO4 gives zinc sulfate, that is ZnSO4 plus hydrogen is H2. We know that when an equal number of atoms of an element is present on both sides of a chemical equation, the equation is said to be balanced following the law of conservation of mass. Now, let us examine the number of atoms of different elements on both the sides of the arrow, that is on the left hand side and the right hand side of the arrow. So here we will first see what are the different elements. Then we will write down the number of atoms in the reactant side, that is on the left hand side of the arrow, and the number of atoms in the product side, that is on the right hand side of this arrow. Here the elements in this reaction are zinc, Zn, hydrogen, then the next element is sulfur, then oxygen. So in this reaction the elements are zinc, hydrogen, sulfur and oxygen. So now we will write the number of atoms on the reactant side. So here the number of atoms in zinc is 1, because here 1 is the coefficient and subscript is also 1. So 1 times 1 is 1. Similarly, on the product side, we have 1 atom of zinc because here the coefficient is 1 and the subscript is also 1. So the number of atoms from the previous video, you know that it is found by multiplying the coefficient and subscript. So here also you have 1 zinc atom. Now let us see how many number of hydrogen atoms do we have. So here 2 is a subscript and 1 is a coefficient. So 2 times 1, that is we have 2 hydrogen atoms on the left hand side, and on the right hand side also 2 is the subscript and 1 is a coefficient. So we have 2 number of atoms of hydrogen on the right hand side. Now let us see how many sulfur atoms do we have. So here sulfur has 1 subscript and 1 coefficient. So 1 times 1 is 1. So we have 1 sulfur atom. Again on the product side we have 1 sulfur atom. Now let us see how many oxygen atoms do we have. So on the reactant side we have 4 times 1, that is 4 oxygen atom, and on the product side we have 4 times 1 again, so it is 4 oxygen atom. When we look at both the left hand side and right hand side of this chemical equation, we find that we have 1 zinc atom on both the sides, 2 hydrogen atoms on both the sides, 1 sulfur atoms on both the sides, and 4 oxygen atoms on both the sides. This shows that this is a balanced equation because the number of atoms of each element on both the sides are same. So we can say that this is a balanced chemical equation. Therefore, when an equal number of atoms of an element is present on both sides of a chemical equation, the equation is said to be balanced following the law of conservation of mass. Children, for balancing any chemical equations, these are certain steps which we need to follow. Now, let us understand all these steps in a chemical equation. The chemical equation is heated iron metal reacts with steam to form iron 2,3 oxide, that is Fe3O4 and hydrogen. This reaction can be written in the form of a word equation as iron plus steam gives iron 2,3 oxide plus hydrogen. Children, we should know something about the various oxides of iron metal. Iron forms 2 oxides. I'll write it here. Iron forms 2 main oxides. They are iron 2 oxide. This iron 2 oxide is written as FeO. This is called iron 2 oxide because the valency of iron in it is 2. So the common name of iron 2 oxide is FeO, that is ferrous oxide. So this FeO is ferrous oxide, and the another oxide is iron 3 oxide. So this iron 3 oxide is written as Fe2O3. Now this is called iron 3 oxide because the valency of iron in it is 3. And the common name of iron 3 oxide Fe2O3 is ferric oxide. Now a third oxide of iron is Fe3O4. Actually, this Fe3O4 is the mixture of iron 2 oxide FeO and iron 3 oxide Fe2O3. So this Fe3O4 is named as iron 2,3 oxide. How? When you add this, see, it is 1 oxygen atom plus 3 oxygen atom. So it makes 4 oxygen atom. And here 1 iron atom and here 2 iron atom. So it makes Fe3, 3 ion atom. So this Fe3O4 is named as iron 2,3 oxide, and the common name of this Fe3O4 is magnetic iron oxide. I hope now you have understood how the formula Fe3O4 forms. Actually, it is the combination of iron 2 oxide FeO and iron 3 oxide Fe2O3. When you add these, it is magnetic iron oxide, that is Fe3O4. So now the chemical equation for this word equation is written as the symbol of iron is Fe plus steam. Here it is important to remember that steam is the gaseous form of water. So the formula of steam is the same as that of water, which is H2O. It gives iron 2,3 oxide, that is Fe3O4 plus hydrogen. So hydrogen is H2. So while balancing, we will follow these steps. So the step is draw the boxes around each formula. This is the first thing we will do. We will draw the box around each of the formula. And why do we need to do this? So that we do not alter the formula of the compound while balancing. So while balancing, we should not make any changes inside this box. Whatever will be written, it will be written outside the box, and nothing should be changed inside the box. Although I have explained this in part 4 of the video of this lesson. Next, we will find out the number of atoms of each element. So, we will list down the number of atoms of different elements present in this unbalanced equation. So, here we will write elements, then number of atoms in reactant side, that is on the left hand side of this arrow, and number of atoms in products side, that is on the right hand side of this arrow. So we will be writing it in this table. Here the elements are iron, hydrogen and oxygen. Similarly here also it is iron, oxygen and hydrogen. So we will write down the name of the elements in this chemical reaction, and after writing the name of the elements and finding out the number of atoms, we will start balancing the equation with the element or compound having maximum number of atoms. So when we observe this chemical reaction, it is seen that here the maximum number of atoms is present in this compound Fe3O4. So we will start balancing from this, and one by one we will balance each element on both the sides. So let us understand this. Here the elements are iron, Fe, hydrogen, and then the another element is oxygen. So these are the elements present in this chemical reaction. Now we will count the number of atoms on each side of this chemical equation. So here on the left hand side, that is on the reactant side, we have one atom of iron, because 1 is a subscript and there is no coefficient, so it is one atom of iron. On the product side, we have 3 subscript and 1 coefficient, so 3 times 1, that is 3 iron atom on the right hand side. Next, hydrogen. So we have 2 times 1, that is 2 hydrogen atom, and on the product side also we have 2 times 1, that is 2 hydrogen atom. And then oxygen. So here 1 times 1, that is 1 oxygen atom, and here 4 times 1, that is 4 oxygen atom. Now the next step we should follow is one by one we will balance each element on both the sides. So when you look at this table, it is observed that the element iron is 1 on the left hand side, 3 on the right hand side. hydrogen 2 on left hand side, 2 on right hand side, and oxygen 1 on left hand side and 4 on right hand side. So this is an unbalanced equation. Now to balance it, we will balance one by one. We will start balancing the equation with the element or compound having maximum number of atoms. So let us start balancing the element or compound having maximum number of atoms. So when we look at this chemical equation, it is observed that this compound Fe3O4 has maximum number of atoms. So we will start balancing from this Fe3O4. Here observe this oxygen atom. It is 4 on the right hand side and 1 on the left hand side. So to make this left hand side 4, what we will do? We will multiply it by 4 as a coefficient. So now both the oxygen atoms are balanced. So we will write the coefficient 4 here. Children, whenever you make any changes, always check both the sides of the chemical equation. So here it is iron 1. Here you have 3. Here you have 4 oxygen. So oxygen has got balanced, but while balancing the oxygen, you have unbalanced the hydrogen atom. Now children, here the key rule is that whenever you make any changes, you count every time both the sides of the atom. So when you wrote 4 oxygen, because earlier it was 2 on the left hand side and 2 on the right hand side, but now it has become 4 times 2, that is 8 hydrogen atom on the left hand side and you have 2 hydrogen atom on the right hand side. So now it is not 2, it has changed. So it has changed to 8 on the left hand side and it is 2 on the right hand side. So to make this 8 on the right hand side, you need to multiply it by 4. So you will get 4 times 2, that is 8. So here you will write the coefficient 4. Now again check. So 4 times 2, 8 hydrogen. 4 times 2, 8 hydrogen. Hydrogen is balanced. Then 4 times 1 for oxygen and 4 times 1 for oxygen. So oxygen is also balanced. So here oxygen is balanced. Hydrogen is also balanced. Now what is left is iron is still unbalanced. So we will balance iron. On the right hand side you have 3 iron atom and on the left hand side you have 1 iron atom. So to balance the 1 iron atom, you will multiply it by 3 on the left hand side. So 3 will be written as a coefficient outside the box. So now iron is also balanced. Again, on rechecking the whole chemical equation, we have 3 iron atom on the left hand side and 3 iron atom on the right hand side. 4 times 2, that is 8 hydrogen atom on the left hand side. 4 times 2, that is 8 hydrogen atom on the right hand side. Then 4 times 1, that is 4 oxygen atom on the left hand side and 1 times 4, that is 4 oxygen atom on the right hand side. Thus we see that this chemical equation has got balanced. So now we can say that one by one we have balanced each of the element on both the sides. Finally, check the correctness of the balanced equations. So we have checked the correctness also. All the elements in this chemical reaction are balanced on both the sides. Then write the symbols of the physical state of reactants and products to make it more informative. Now, to make the chemical equation more informative, we will write the symbols of the physical states of the reactants and products. So here iron is solid in state. This water in the form of steam is gaseous in state. Then this Fe3O4 iron oxide is solid in state. and 4H2, this is gaseous in state. So this is a complete balanced equation. This way of balancing is by hit and trial method. Now let us balance the same chemical equation by the second method, that is algebraic balancing method. Let us understand this one. Let me first write down the chemical equation for the same. It is iron plus water in the form of steam gives Fe3O4 plus H2. Now in this algebraic balancing method, we will write down the alphabets as the coefficient. So let us write down A for iron, B for water, C for Fe3O4 and D for hydrogen as the coefficient. Now the same thing, the chemical equation must follow the law of conservation of mass. So we will first write down the elements which are present in the chemical reaction. So we have iron, we have hydrogen and we have oxygen. Check, it is iron. Here also you have iron, then hydrogen on the reactant side, and here also you have hydrogen on the product side, and then oxygen on the reactant side and oxygen on the product side. So we will write down the name of the elements which are present in the reaction. Now as you know that the chemical equation must follow the law of conservation of mass, means the mass of the reactant should be equal to the mass of the product. So for this iron element on the reactant side, you have 1 times A is equal to, on the product side you have 3 times C. So you have 3C. And why I have put this equal to sign? It's because the chemical equation must follow the law of conservation of mass, means the mass on both the sides should be equal. So here equal to sign has come. Now for this hydrogen, let us see. So it is 2 times B on the reactant side. So it is 2B on the reactant side. This is equal to, for this hydrogen you see, it is 2 times D on the product side. So here 2B is equal to 2D. Now for oxygen, so it is 1 times B on the reactant side, and here oxygen 4 times C on the product side. So B is equal to 4 times C on the product side. Now after getting this equation, here the key rule is that assume any of the alphabet which is repeated more times to be 1. Here the alphabet A is written only once. Okay. Now look at C. The C is written 1, 2 times. Then B, so B is here and here 2 times. So B is written 2 times. Then C, 1, 2 times C is also written. Then D is written only once. So we can either assume B to be 1 or C to be 1, because both of them are repeated more number of times. So here let any of it, either B or C, to be 1. So here I'll take B. So let B is equal to 1. Now when you assume B to be 1, so put this value now here. So 1 is equal to 4C. From simple mathematics, C is equal to 1 by 4. So here you have got the value of C as 1 by 4. The value of B as 1, which you have assumed. Now put the value of this C in this equation so that you can get the value of A. So the value of A, you will get A is equal to 3 times C. C is 1 by 4. So it will become 3 by 4. So you have got the value of this A as 3 by 4. Now what is left? Yes, you have to find out the value of D. From this equation, 2B is equal to 2D. Put down the value of B so that you can get the value of D. Here B you have 1. So 2 multiplied by 1 is equal to 2d. So from here d will be 1. So now you have got all the values of the algebra that you have written here. So you have got the value of A as 3 by 4, B as 1, C as 1 by 4 and D as 1. So now you will put the value of these alphabets in this chemical equation. You will get 3 by 4 Fe plus B is 1. So 1 H2O gives, then C is 1 by 4. So 1 by 4 Fe3O4 plus D is 1. So here 1 H2. Now children, see, this 3 is the numerator and 4 is the denominator. To make these fractions into whole number, you will multiply both the sides of the equation by which number? Yes, by 4. So when you multiply both the sides by 4, the denominator will get cancelled. See, 3 by 4 multiplied by 4, Fe. So this 4 and this 4 is cancelled. So you will get 3 Fe plus 4 times 1 for water. So 4 H2O gives this 4 and this 4 got cancelled. So Fe3O4 plus 4 times H2. So here it is 4H2. So now this fraction has got changed into the whole number. So this is the balanced chemical equation by algebraic balancing method. So you have 3Fe plus 4H2O gives Fe3O4 plus 4H2, and this is the same that you had with the hit and trial method. That is 3Fe plus 4H2O gives Fe3O4 plus 4H2. Now the same thing, to make the equation more informative, you will write this iron is solid, water in the form of steam is gaseous, then Fe3O4 this is solid and 4H2 this is gaseous, and this is a balanced chemical equation. Children, we will practice some more balancing of chemical equations to make it more clear. Let us see another example of chemical reaction of photosynthesis. In the process of photosynthesis, the word equation is written as carbon dioxide plus water in the presence of sunlight and chlorophyll. This sunlight and chlorophyll is the reaction conditions which is written above or below the arrow in the equation. As we already know from our previous videos, it gives glucose plus oxygen gas, and the chemical equation for this word equation is written as CO2 for carbon dioxide plus water H2O gives same thing, the reaction conditions such as sunlight and the green pigment called chlorophyll is written above or below the arrow gives glucose. So the formula of glucose is C6H12O6 plus O2 for oxygen. Now, in order to balance this skeletal equation, we need to follow the steps which we have already learnt. So these are the steps. The first thing we need to do is to draw the boxes around each formulas and do not alter the formula of the compound while balancing. So let us draw the box around each formula. This is glucose and this is oxygen. We draw boxes around each formula so that we do not alter the formulas, and whatever coefficients are added, it is written outside the formula. Now the next step is to find out the number of atoms of each element. Now we will list down the names of all the elements present in the reaction. Here in this reaction we see that the elements are carbon, hydrogen and oxygen on both the sides. Now we will count the number of atoms present in the reactant side, that is on the left hand side, and the number of atoms in products side, that is on the right hand side of this arrow. So let us draw a table and list down all the elements present in this skeletal equation. Now let us count the number of atoms present in this skeletal equation. So for this carbon element, the number of atoms of carbon present is 1 is a subscript and 1 is a coefficient. So 1 times 1 is 1. And on the product side, the number of atoms of carbon present is 6 is the subscript and 1 is the coefficient. So 6 times 1 is 6. Next is hydrogen. So hydrogen is 2 times 1, that is 2 on the reactant side, and 12 times 1, that is 12 on the product side. Next is 2 times 1 is 2 plus 1 times 1, that is 1 oxygen atom. So on the reactant side we have 3 atoms of oxygen, and on the product side we have 6 times 1 plus 2 times 1, that is 2. So on the product side we have 8 oxygen atoms in total. Now we need to follow the next step. The next step says that we should start balancing the equation with the element or compound having maximum number of atoms, and one by one we will balance each element on both the sides. So let us see which element has maximum number of atoms. So here the maximum number of atoms is seen on the product side, that is for the element hydrogen it is 12. So we have 12 hydrogen atoms on the product side, and on the reactant side we have 2 atoms of hydrogen. So we will start balancing from this hydrogen atom because it has maximum number of atoms. So to balance this hydrogen atom, multiply this hydrogen atom by 6 so that we have 6 times 2, that is 12 hydrogen atom on the reactant side. So here this hydrogen atom we will make it 12 by writing the coefficient 6. Now again recheck. So now we have 6 times 2 for hydrogen atom, that is 12 hydrogen atom on the reactant side, and 12 times 1, that is 12 hydrogen atom on the product side. But while balancing this hydrogen atom, now the oxygen atom on the reactant side has changed. It has become 2 times 1 plus 1 times 6, so 6. So now the oxygen atom has become 8 on the reactant side, and yes, we have 8 too on the product side. So it has automatically got balanced. So now check again the whole equation. So we have carbon 1 on the reactant side, 6 times 1, 6 on the product side. For oxygen 2 plus 6, that is 8 oxygen atom on the reactant side, and here also 6 plus 2, 8. So 8 oxygen on the product side. So oxygen has got balanced, hydrogen has also got balanced, but still carbon element is unbalanced. So in order to balance this one carbon atom on the reactant side, we need to multiply it by 6. So it becomes 6 carbon atom on the reactant side, and we already have 6 carbon atom on the product side. So this carbon atom 6, we will write it here. Now again a recheck from the beginning. So 6 times 1 6 carbon atom, and on the product side 6 times 1 we have 6 carbon atom. So this carbon element is balanced on both the sides, left hand side and right hand side. Now let us check another element. So now the number of oxygen atom is not 8 on the reactant side, it has changed. 2 times 6, that is 12 oxygen atom, plus 1 times 6, that is 6 oxygen atom. So now in total we have 18 oxygen atom on the reactant side. Now let us check the oxygen atom on the product side. So we have 6 times 1 6 plus 2 times 1 2 is equal to 8. So but we see that here oxygen atom is now unbalanced. It is 18 on the reactant side and 8 on the product side. In order to balance both the sides, we need to make this 8 into 18. So to make this 8 into 18, if we write the coefficient 6, so now let us see how many oxygen atoms do we have now. It is 6 times 1 6 plus 2 times 6, that is 12 oxygen atom. So now we have 6 plus 12, that is 18 oxygen atom on the product side as well. Let us check from the beginning again on both the sides. So 6 carbon atom on the left hand side and 6 carbon atom on the right hand side. So this carbon atom is balanced. Next is hydrogen atom. So 2 times 6, that is 12 hydrogen atom, and here 12 times 1, that is 12 hydrogen atom. So hydrogen element is also balanced. Next 2 times 6 12 plus 1 times 6, that is 6. So 12 plus 6 is 18 on the left hand side, and here 6 times 1, that is 6 plus 2 times 6, that is 12. So 12 plus 6 makes 18. So here oxygen is also balanced on both the sides. Now the balanced chemical equation is 6 CO2 plus 6 H2O in the presence of sunlight and chlorophyll gives C6H12O6 plus 6O2. So this is the balanced chemical equation by hit and trial method. Now let us balance the same chemical equation by algebraic balancing method. Let me write this same equation here. So CO2 plus H2O in the presence of sunlight and chlorophyll gives C6H12O6 plus O2. So for this algebraic method, let us write down the coefficient A for carbon dioxide, B for water, C for glucose, and D for oxygen. Now we will find out the values of A, B, C, D. So for this algebraic balancing method, first we will write down the elements. So the elements are carbon, hydrogen, and oxygen. So for this carbon element we have 1 times A, that is A carbon atom on the reactant side is equal to 6 times C, that is 6C on the product side. Here I have written this C, but don't get it confused with the formula of carbon. This is the alphabet C and not the formula of the element carbon. Next, for this hydrogen we have 2 times B on the reactant side is equal to 12 times C on the product side. So it is 2B. So 2B is equal to 12C. Now let us see for this oxygen. So we have 2 times A plus 1 times B on the reactant side. We already know that in algebra we do not mention 1. So we will write just B here. Now this on the left hand side is equal to on the right hand side. So this oxygen atom on the right hand side is 6 times C. So it is 6C plus 2 times D. So it is 2D on the product side. Now, as I had already explained, we will assume alphabet value which is repeated more than once to be 1. So here we have A and A. 2 times A is written. Then for C, 1, 2, 3. So C is written 3 times. Let us check for B also. So here B is 1, 2. So B is written 2 times. And then for this D is written only once. As I have already mentioned, we will assume any of the value of the alphabet which is repeated more times to be 1. So here in this chemical equation, C is repeated 3 times. So we will assume C to be 1. So here we have got the value of C as 1. Now putting this value of C as 1 here, we will get the value of A. So here we are given A is equal to 6C. We will put the value of C as 1. So we are getting A is equal to 6 times 1, that is 6. So the value of A is 6. Now let us find out the value of another alphabet. So here it is given 2B is equal to 12C. So we will find out the value of B. 2B is equal to 12C. Now put the value of C here. So we have the value of C as 1. So 12 times 1 is 12. So now take out the value of B. So B is 12 by 2. So we are getting the value of B as 6. Now let us take out the value of D from this equation. So here we have 2A. And we have already taken out the value of A as 6. So it will become 2 multiplied by A, which is 6, plus B. So here we have taken out the value of B as 6. So we will write B as 6 is equal to 6C. So 6 times C, and C is 1. So 6 times 1 plus 2D. We have to find out the value of D. So we will write it here 2D itself. So now the equation becomes 12 plus 6 is equal to 6 plus 2D. We have to find out the value of 2D. So 2D is equal to 12 plus 6 and minus 6. Now on solving mathematically, we get 2D is equal to 12. Therefore, D is equal to 6. So we have got the value of D as 6. Thus we see that we have the value of A as 6, B as 6, C as 1 and D as 6. So put down all these values here. So from here we will write down the values of these alphabets. So here we have A is 6. So 6 CO2 plus B is 6. So 6 H2O in the presence of sunlight and chlorophyll gives C, C6H12O6, and the value of C is 1. So here we know that we do not write 1. So here it will be 1 times glucose plus DO2. So D is 6. Thus we see that the final equation is 6 CO2 plus 6 H2O in the presence of sunlight and chlorophyll gives C6H12O6 plus 6O2. Thus we see that this is also the balanced chemical equation by algebraic balancing method, and it is the same as what we are getting by hit and trial method. Now the last step is then write the symbols of the physical state of reactants and products to make it more informative. So this is also the balanced chemical equation where we are getting 6 CO2 plus 6H2O in the presence of sunlight and chlorophyll gives C6H12O6 plus 6O2. And by algebraic balancing method, again we have 6CO2 plus 6H2O in the presence of sunlight and chlorophyll gives C6H12O6 plus 6O2. Children, I hope you have understood how to balance the chemical equation. In the next video, we will practice some more balancing. Till then, keep learning, keep growing. This is Anupama Ma'am signing off.